All right, so this is an interesting problem, and a lot of students come across this at some point or another and come and ask me about this. So let's go ahead and look at this table here. So again, notice we have no descriptions for x and y, we just have some values, right? We want to figure out the slope and the y-intercept of this table. That's what we've been talking about. So slope was that change in the y values compared to the change in the x values, because it's a rate. And in rates, we do comparisons, right? So we're comparing the y value change to the x value change. So on the x, notice it goes up by 1. 1 plus 1 is 2. But then to get from 2 to 4, it goes up by 2. And then from 4 to 6, yeah, it goes up by 2. Then on the y, from 65 to 60, it goes down by 5. But hold on, just like how on the other side it got a little funky, it's getting funky over here too. So now we'd have to get rid of 10. So what do I do when it seems like there's no constant rate of change? A lot of students come up to this point and they say, well, Ms. Metcalf, it's not the same. It's not happening the same way on the y each time, and it's not happening the same way on the x each time. And so what I've shown students to do is you actually take each change as its own comparison. So what I mean by that is that first change in y was -5. Take that and compare it to its corresponding change. And again, when I say that, I mean take this -5 and compare it to its 1. And then we're going to take this -10, which is a different comparison to the 2, right? And then we're going to simplify them. Okay, since those are a little funky, we're going to go off and do that. So notice -5 over 1 is -5, right, when we divide those. -10 divided by 2 is -5. So the point is, when it seems a little weird, just take one of the changes that's happening in the y's and put it over the corresponding x change. And then when you do one of the different ones and you match it to its corresponding and you simplify, you will end up with the same amount or the same number for slope. In other words, there is a constant rate. They just stopped showing you the in-between. And if you think about it, you could fill in 3 here and in between, because in between 2 and 4 is 3, and then in between this would be the 55. And then it'd be going down by 5. If you're more comfortable doing that, then figure out a pattern and do that. But either way, that's how you can figure out the slope is -5. Now, what about that y-intercept? We've been talking about the beginning, and we've been saying that this table, even though it starts with 1, yeah, that's the beginning of this table, but when we mean beginning, we're talking about like the beginning of your life, like 0 old, right? Some people joke and say you're like, and then your parents are like, oh, she's a day old, 5 days old, whatever, and then they go to weeks and months, and then start talking about years of age, right? So it's that 0, that very beginning point. So what if we had x of 0? So again, if we had kind of followed the pattern, and if we're thinking about it going this way, if I take 2 and subtract 1, I get this. So if I subtract 1 again, I would get 0 here. So I have to add 5 to go here. So if I add 5 there, that means when x is 0, y would be 70. And that beginning, we know that when we find that beginning, that x value where it all begins, that's 0. Whatever x is, whatever y is when x is 0, that's your y-intercept. So 70 would be our y-intercept. Okay. So that's, again, just a little special situation that some students kind of get a little confused on, in case you come up with any problems like that. All right, well, I hope all of this information has been helpful to you guys. Remember to reach out to me, Ms. Metcalf, or your math teacher if you need any more help and guidance, all right? And we're all in this together. You're going to do great. If, something goes weird, we'll talk to you about it and, redo it, okay? Don't stress too much. Just talk to us about it. Have a great day.